Good morning. So today we're going to talk a bit more about outliers. So this is something that we talked about earlier in the semester, but we treated a bit casually. So today we're going to look at a little more detail of how this affects different summary statistics and how we should handle these outliers. So as a warm-up, remember that we had talked about in our summary statistics, we had looked at these two terms. We had looked at Q3, and this was the point that 75% of the data fell below this point. And remember that we had also said Q1, and this was known as the first quartile, where 25% of the data was below this number. And we had talked about the median, which was the point in between these where 50% of the data fell below it. So there are many definitions for outliers. One common definition that we typically see is we see that an outlier gets called any point that lies more than 1.5 interquartile ranges above or below these Q1 and Q3. So this interquartile range is exactly the difference between these two. So this interquartile range essentially says that 50% of the data falls between these 2 points, and then this we say if it's more than 1.5 times that interquartile range above this upper point, or 1.5 interquartile ranges below this lower point, then we call that an outlier. Now when we do box plots in R, as we've often done, remember they often take on some form that looks like this. And when we have the box plot that looks like that, the center line in this box is actually the median. It's the 50% point. So that's not the mean of the data, that's the median of the data. The upper line of the box is this Q3. The lower line of the box is this Q1. So that's Q3. That middle point is the median, and the lower point is my Q1. And then these lines show how far out the data go that's within this 1.5 interquartile range. So any dots that you see on the graph, such as this point here, is exactly an outlier. It was exactly calculated by R as being more than Q3 plus 1.5 interquartile ranges beyond this point. This is the most common definition that we see of outlier. There are others as well, but these outliers have the possibility of very seriously altering our analysis if we choose to leave them in. So I'm going to put a question on the board for you to think about, and then there will be a space in the video for you to actually answer this question. So I want to think about how these outliers affect the different summary statistics that we typically look at. Better dry the board down. So what you need to think about is how much does the presence of outliers affect each of the following summary statistics. We're going to say, how does it affect the mean? How does it affect the variance? How does it affect the median? How does it affect the mode? And how does it affect the range? So take a minute, go back in your notes and review the formulas for what each of these were, to think about how these outliers, how these points that are really far beyond where the rest of the data tend to lie, how they're going to affect these three measures on a scale from not much, some, and a lot. Okay, now you've had some time to think about it, to answer the quiz questions. What I hope you came up with was, for affecting the mean, how much does an outlier affect the mean? The correct answer was some. It affects the mean. It can affect it by a good amount. Remember, when we say mean, we just mean the simple average of all of the points that we've seen. So depending on the size of your data, depending how many data points you have, an outlier is going to pull that up a little bit. Maybe by some, maybe not by a ton. Variance, on the other hand, remember the formula involved the squares of how far is each point from the mean. So if you have a point that's really far away from the mean, like an outlier is, then when you square that distance, it's tremendously affecting the data. So this variance is actually affected a lot by the presence of outliers. The further out this point, this outlier point is, the larger that square of the distance between it and the mean of the rest of the data is going to be. So this can tremendously increase your variance. Even a single outlier can skew your variance really high. How much does outlier affect the median? Well, the answer would be not much. Remember that the median is the point that 50% of the data lie below it. So if you have an outlier that's really far out there, it might push the median up a little bit, but the scale of that outlier is not going to affect it. So say, for example, that you had some points. Let's say we were looking at the garlic mustard plant height, and let's say we had something like 75, 78, 80, 80, 81, 85. Well, we could do some calculations on what the mean and the variance and the median and the mode and the range were. But now let's say that actually I had one other point in here. It was an outlier point. Let's say this was something like 120. Well, how much is that going to affect the mean? Well, now instead of averaging over these 6 numbers, we're averaging over these 7, so it might increase the mean by a little bit. How much is it increasing the variance, though? Well, now I'm talking about the square of 120 minus the mean here is maybe something like 80, so that affects it tremendously. But what does it do to the median? Instead of the median being 80, now the median might be 80.5 with the addition of one outlier point here. So that's why we say it doesn't affect the median much at all. What about the mode? Remember, what was the mode? The mode was the most often occurring data point, the most frequent observation. So in this case, my most frequent observation would be 80. So in fact, this mode is affected not much, or really even not at all, by the presence of outliers. Because you can think about a larger data set. If my n was actually 10,000, if I actually had 10,000 data points, having one point that's extremely far out isn't going to affect in the slightest what the most common observation is. Finally, how much is the range affected? Remember, the range talks about the maximum value minus the minimum value. So the range, a lot like this variance, is also going to be affected a lot. Very much. The range and the variance tend to capture how spread out are the data, and if we have a point that's extremely far outside of where the rest of my data lie, then it also is going to affect this variance and this range that try to capture how spread out is the data. This outlier makes the whole data set more spread out, whereas the mean and the median capture some central tendency of the data, and so having a point that's far out is not going to affect that central tendency as much, although in the case of the mean it still affects it somewhat. So the next thing that I'd like to have us think about is, how should we handle outliers? What should we do with them? Should we get rid of them? Should we try to transform them somehow? Should we leave them in the data set? Take a few seconds to think about that, and then answer the following quiz question. So the question involved, what should we do with these outliers? Should we throw them out? Should we leave them in the data set? Does it differ from case to case? The correct answer, as I hope you discovered, was it really differs by case to case. So we don't want to just make a blanket rule that says, let's just throw out all of any outliers that we have. Then we're potentially getting rid of a very interesting point. Oftentimes in science, the most interesting points are the outliers. So here's a story I wanted to share with you that back in the 1980s, when NASA was had some satellites out and was looking at whether or not there were holes in the ozone layer. Well, a bunch of other countries were investigating this as well, and America sent some satellites up to try to gather some information to say, is there a hole in the ozone layer or not? And in fact, American satellites and NASA entirely missed that there was any problem and that there was any hole in the ozone layer. They said, no, everything is good. The other countries, Germany and Britain and France, all found problems, and they said there is a huge hole in the ozone layer. What happened? How did NASA miss it? Well, it turned out that in NASA's code was a bit of code that said, if this point is an outlier, if this point is really far exceeding what we expect the average is going to be, it must be an error in the measurement, so discard it. By doing that, they actually missed how large of a problem this was. Turns out the hole in the ozone layer was so much worse than anyone had anticipated or anyone had thought, that they thought all of these points they were seeing were outliers and they threw them out, and all they were left with were a few measurements that said, yes, everything's okay. So by automating that process and saying, let's get rid of everything that looks too large, looks larger than I think it should be, they in fact missed the central point. So the correct way of treating outliers really is on a case-by-case basis. The first question to ask yourself with outliers is this number reasonable? Is there something sensible about this number, or is this totally unbelievable? Now, if you're looking at something like weight of a person, and you get a negative number, you get -20, it's clearly nonsensical. It's clearly an error in the coding, and we should throw this number out. Similarly, if you can go back and confirm, if you have a number in your data set that says, this plant was 700 centimeters tall, but then you find written in an article somewhere that someone acknowledges, yes, I was counting millimeters instead of centimeters, so 700 millimeters was actually 70 centimeters here. If we find out that it was an error, then we can throw it out. Or for example, the person had said it was 700 centimeters, but I mistyped into the keyboard and made a mistake, then we can throw that number out. We can get rid of it from our data set. However, it's still worth mentioning in any report that you do how you've handled the outliers, how many of them there are, and whether you've included them or excluded them from your analysis. Let readers decide how to interpret that. Now, one common strategy that often gets used with outliers is to run the analysis two ways. To first run the analysis with all of the data intact, and then to run the analysis with all of the outliers removed. And what we hope to see, what we would like to see, is that those analyses agree. Of course, the exact numbers are not going to agree. Of course, the mean and the variance are going to be different, but we'd hope that the core message stays the same. If we're comparing two or more groups, we hope it would be about the same. And we hope that in the case of doing a linear regression model, we hope it might be about the same as well. However, if these analyses differ, as they sometimes will, sometimes these two groups will not be significantly statistically different with the whole data set with the outliers intact. But if you remove the outliers, then they are statistically significantly different. Then you have to really think even harder about where these outliers are possibly coming from. Is this number a representative number? Was this just some anomaly, if this was just one case where this happened? Or was this truly a likely outcome? So for example, if you were looking at the N-Haynes data set, and we were looking at if we were comparing the weight of males and females, we would probably find a great number of outliers. If you were to do this analysis, we would probably find a lot of people who may be morbidly obese, who may weigh 400 pounds that would be in the data set. Now there would be no reason to exclude that from the data set, even though statistically, I've erased it now, statistically it would fall more than 1.5 interquartile ranges above Q3. We know these are valid measurements. We know these are people that have this weight, so it wouldn't quite be appropriate to discard them. We really should leave them in this data set anyway. That's about all that I have to say right now for outliers. Thank you for listening.